think in science it's usually called like a snowball thing, so I don't know if that counts as being it.
Huh. There's nothing to say click on. Oh, it's going now. So, we've got it now. The lights are flashing. There he is. Hurry up, Zach. We need your expertise again. Set up the
now.
Yep.
You want the whiteboard up?
Yep. We're already broadcasting, so you can.
It's easy.
Show your
Tap. Switch. You don't. I have to open it first. Right, there it is. On smartboard. Share, and there you go. You're broadcasting the smartboard now.
Great. Okay. Thank you. All right. Okay, so we're going to finish this section today. It's the third lesson on trigonometry. There's two things I need to look at today. One is area of a triangle, and the other is I need to look at radial surveys again. So there is a formula for area of a triangle, which is
half base times height.
well, this is the normal one. Well, I shouldn't say normal, the one that you're used to using. It's your standard formula for the area of a triangle, provided that you have the height of the triangle, or given the height of the triangle. But in the trigonometry section, you'll often get a triangle where you don't have the height. Okay, and so you have to use this other formula, which says that the area of the triangle A is equal to half side A times side B times the sine of angle C. So if I label my triangle A, B, and C as the angles, then that would be side B, side A, side C. So if I'm using side A and side B, then angle C is the included angle. Okay? Nothing difficult about it. It's just that everyone seems to forget about this rule. Every time a question comes up in the test for an area of a triangle, people go straight to the half base times height, and it just gets forgotten about. Okay? So if you've got a question on trigonometry, and then they ask you for the area, then chances are you'll have to use this formula here. Okay, don't need to say anything anymore on that. It's pretty self-explanatory. Okay, next one. Okay, so we go back to radial surveys again, and I'm going to look at the one on page 24. I'll quickly sketch it up. And these are my radials. And they give you the lengths of each radial. For example, radial B is 3.1 meters, and it has a bearing of 0.35 degrees. They often give bearings with 3 numbers. So 35 degrees would be 0.35. What's up, Zach?
Second. Do you have Tim's book?
No, I
Tim's book?
need the exercise book.
Okay, no, I don't have a spare copy on me right now.
That's fine.
Just have a look on.
No, I'm gonna head off early.
I do,
Yeah,
but you were given the book though, weren't you?
I haven't been the last 2 weeks. I know.
Yep. I don't have a spare copy on me right now because we've just moved everything.
Okay, yeah, it's just all up. The stuff that I need to do is just all online.
Pretty much, yeah, because I've
Okay.
recorded the last 2 sessions and I'm recording this one.
Yeah, and there's a PDF with them. Does that do work?
No, I haven't put the paper up. Sorry, haven't done that.
That's fine.
Okay.
I'll have to grab it off you next week then.
Yep.
Really buckle down working on it.
Okay.
Sorry to interrupt.
No, that's all right. I just don't have a copy on me because of all the movement that's happened.
Yeah, could you, if you get a copy, could you just give the Anne then?
Yeah, I will. Okay.
Thank you.
Yep. All right, so 35 degrees or a bearing of 0.35 degrees. Now, quite simple. You just have to remember it's always taken from north. So you always have to put your north point in first. Yeah. So that 0.35 degrees is 35 degrees from the north, okay? And then you take the next bearing down here, which is 120 degrees. Then that bearing again is taken from north, around 20 degrees, and so on. And you've got the third bearing, it's 2, 4, 3 degrees. And the last one, A, which is 301 degrees. Green, so 301 again from north, so all the way around to there, 301 degrees. Now, very common HSC question. This length as well, 4.2 meters, is they usually ask you for this angle in here. So I better label my corners. A, B, C, and D. And 0 for the origin, the center. So that angle is going to be angle AOB, which will be written like this. Angle AOB. Okay, if you look at the diagram, we've already got that part in there, which is 35 degrees. And then the second part in there is going to be 360, take away 301, which is 59 degrees. 59. And so our angle is going to be equal to 59 plus 35. 94 degrees. Okay, Jack? Pretty simple, yeah? That's a very standard question. They'll ask you to find that angle first, and then they'll ask you to find this length across their side AB, for example, we'll call that X, say. So side A, B, so two letters denote the length, equals X, equals, and what rule are you going to use to work out that length? First of all, you look at the triangle. Is it a right angle triangle? No. So it's not going to be SOHCAHTOA. It's a non-right angle triangle, so you've got two choices. You've got the sine rule and the cosine rule. Which one's it going to be, Vanessa? What have we got? We've got 4.2 and 3.1. We've got two sides.
Sine,
Well,
cosine.
it's got to be one or the other, doesn't it?
Cosine, because you've got two sides which
Two sides and the
angle in between.
included angles, what I'm looking for. We've got two sides and the angle between the included angles, that's got to be the cosine rule.
Let's use the c squared plus b squared equals a squared. Well, a squared plus b squared equals c squared.
No, because that's
Not right angle.
yeah, right angle triangle. All right, so cosine rule. What colour am I in? I can't remember. So equals, and I just put down here, use cosine rule, which is going to be what I'm looking for, x squared is going to be equal to 4.2 squared plus 3.1 squared minus 2 times, I'm going to run out of space, 2 times 3.1 times cos 94 degrees. Okay? I'll leave that for you to work out. Okay, so that's pretty much, that's the main difference, I think, between the traverse surveys and the radial surveys. With traverse surveys, because you're operating on one central line and all your offsets are at right angles, then you can calculate the area using just your half base times height, can't you? Because they're all nice right angle triangles or trapeziums, okay? It's not until you get to the radial survey that you end up with triangles that are non-right angle triangles. And therefore you have to use either sine rule or cosine rule in order to find angles or the lengths of the radials. Okay, is that clear? So that's why they've gone back to that, because we did it in the last section. So we're back here. I remember exactly when. But they've come back to them again because we had to do the sine rule and the cosine rule and then go back to the radial survey so that we could use those rules to find the areas. Okay. Is there any questions on that? Any questions? Jack? It's all very clear? Yeah, down the back. Quinlan, are you okay with that?
Yeah, I just don't have a calculator, so.
Don't have a calculator. Zach, all right? Good. Okay, that's just the recording I'm going to do for today. It's all finished, so it's there for you if you want to review it again later. Okay, so we'll just get you started on some of those questions just to practice them a little bit. You've got worksheet 6, area of triangles, and worksheet 7, surveys again. And lots of practice on the first one. Okay, Zach, what do I do again now with this?
Well, go back to the camera.
Yeah, so I hit this one. Or
You hit that and you press stop. Not stop broadcast, the green one. Go top of the screen. You see the skewer screen sharing?
Yeah.
Next to that is stop button. Press that. And there you go.
Well, I can stop the broadcast now anyway.
Oh, listen, you can set the broadcast.
Yeah.
Oh,
So